Alrighty. Okay, class.
Yes.
That was super weak. We gotta try that again. Let's try it. Hey, you guys make me feel it. Seriously, I get it's a Monday, but you guys had an extra hour of it to sleep in. Come on now. Let's try this again. Class.
Yes.
That's better. Okay. At least fake it for me, please, because I have to artificially make myself happy to be here. Okay. There is not enough coffee in the world to make some people want to hang out with Diego. But
Yeah, for sure.
I do my best. I do my best, all right? Speaking of coffee, I just made a new pot. You guys brought your cup? Okay. All right. So using definitions of the trigonomic functions. Now, all these things I kept teaching you, what are the three things of every trig identity that you have to know? Okay, to know that, what are the three things you got to know for those? X, Y, and R. X, Y, and R. All the time. X, Y, and R. This whole year, X, Y, and R. Everything we're going to cover is going to be X, Y, and R. Everything is based in that. So once you guys get those patterns down and all those things do very well, you'll be good. So these are reciprocal identities. Okay. All you need to know is sine is y over r and cosecant is r over y. These right here, writing it out like this is kind of a pain, but just so you know that they do go together. Okay? So blah, blah, blah. Find cosine given that secant is 5 over 3. Okay? What do we know secant is? So if you had your notes from the other day, what does secant represent?
Secant is like the opposite.
Oh, find from the notes. R over X. Where do you find these notes? 1.3, right? 1.3. So let's go ahead. So secant, we know, is given to us that it's going to be R over X. This is given to me. That's super important. Since that's given to me, the three things I need to know is X, Y, and R. Agree? Okay, so now, if I gave you the R is 5, and the X is 3, what are they asking for here? They're asking for, okay, they're asking for cosine, right? Find cosine. Find cosine. We know cosine theta. What does cosine represent? R, X, which is it? X over R, very good. So you guys are staring at those notes also, right? That table of stuff is going to be super important. So this is X over R. Okay, do I need to do anything more? I don't have to find anything else because what did they give us? They give us the R and the X, and they're asking for X and R. So what do I do with that information? Just plug it in, right? So my X value is 3. My R value is 5. Does that make sense or is that nonsense? Is that too many words? Are we good? Okay, so if you have the 1.3 notes out in front of you, that's going to be super helpful for all these things. Let's go back and look at the next one then. It says find sine theta. Let's look. So sine theta. So from the 1.3 notes, sine represents what? Y over R. Very good. So Y over R. Okay. Cosecant. What does cosecant represent? R over Y. R over Y. Cosecant is R over Y. Anyone here getting lost? Okay, you guys understand. This is straight from the table on 1.3. Straight from that table. Now, let's go through and fill it out. So off to the side, I'm going to say X, Y, and R. because those are three things I always need. What is my R value here? Square root of 12, right? Sorry. The air blowing in my ear, I can't hear. Okay, so we know that R is going to be radical 12, right? Why is it negative? Is it negative?
Yes. No. Or the whole thing is negative.
The whole fraction is negative.
The whole fraction's negative. But what do we know about the R value?
It can't be negative.
It can't be negative. Why?
And that's
The radius
Radius, and the radius is a
can't have a negative one. Can't be negative.
is the radius. Think about radius. Where we get radius from? It's the center of a circle, right? And is that the distance from the center to the edge? And can we have negative distance?
No.
No negative distance. So can R ever be negative?
no.
R can never be negative. Now, so that means that 2 has to be negative, right? So that's going to be my Y value is negative 2. Now we're going to do some factoring also. So that radical 12, I'm going to break it up. I don't know if you guys done factor trees before, but I'm going to look for a perfect square. So perfect squares are like, let me see, 1 is a perfect square, 4 is a perfect square, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Is that, yes? Makes sense, kind of, remember? Okay, perfect square is just number times itself. So, I'm going to break this up. Is there a perfect square in that 12 that I want to take out of there? Give me two numbers that multiply together to give me 12. Is there a perfect square there? 2 and 6, but is either one of those a perfect square? No. 4 and
3.
4 and 3, right? So 4 and 3, that's why I want to use this. 4 times 3 is 12, isn't it? So 4 times 3 is 12, but is 4 a perfect square?
Yes.
What is the square root of 4?
2.
2. So this is a perfect square. So inside here, I'm going to have square root of 4 times square root of 3. So by factoring this out, it's going to simplify the fraction sum. So square root of 4, do we know what square root of 4 is? It is 2. And then that square root of 3, I just leave it alone. Okay, so let's go back over here. So as I do this, my R value is now 2 square root of 3. So let's plug them in. So my Y, we said, is negative 2. My R is 2 radical 3, right? Why am I not using square root of 12? I reduced it, I factored it, so since I could do this, it's still equivalent. So if you want to look at it and put in the calculator, what is square root of 12? You're going to get 3 point something. And if you put in 2 rad 3, you also get 3 point something. You'll get the same answer. They are equivalent. It's just this one is factored. That one is factored out. This one is not factored. Does that make sense? Or no? Maybe? I know the algebra teams did not do this very good at all, if they even taught it at all. So they did not go over factoring these things. Now, what's going to happen if I have a 2 on top and bottom?
They get canceled out, yeah.
Cancel it, so I can do that, right? So what's left if I cancel out everything on top? No. If I cancel everything, what is 2 divided by 2? 1. There's always 1 there. There's always 1. So when I cancel it out, I'm saying, what is 2 divided by 2? It's 1. So there we go. So I have a negative 1 on top over
Square root of 3.
square root of 3.
You can't have square root on the bottom.
I cannot have square root on the bottom.
So we're gonna multiply
Yep, but what is that process called?
Rationalizing.
Rationalize. We are going to rationalize this problem.
Is it gonna be -1 rad 3 over 3?
And so as you multiply straight across, very good. So it's -1 times rad 3 is negative rad 3 over 3 times 3 is 9.
And then take the square root of that's 3.
And square root of 9 is
3.
3. So when I multiply two radicals together like that, it's actually canceling out the radical. So I should be left what's inside. So rad 3 times rad 3 is rad 9, or square root of 9, and square root of 9 just is 3. And that is the final answer there. So that's the process with some factoring. And do I have a part C on this one? This problem? Okay, so let's go ahead and keep going. Blah, blah, blah. Oh, okay. See this right here? I hate the way they do this. This is better. It's better, but it still sucks. So this is what you guys are going to do. So off to the side. Okay. We know that this is x, comma, y, right? Yes? Okay. So let's take a look. X and y are both positive in quadrant 1, isn't it? And what do we know about the r value?
It's always positive.
Very go. R is always positive, right? Okay, so that's good. So we have positive, positive. So now let's go to quadrant 2. In quadrant 2, it's negative x, comma, y. Now to get a negative, think about this. To get a negative in a fraction, what happens? How do you get a negative?
In a fraction.
Are they both negative? What happens when you have two negatives?
You have 2 negatives, they turn into a positive.
It becomes a positive, right?
Uh-huh.
What happens if you have one negative?
It stays negative.
It stays negative, right? But we know the r value is always going to be
Positive.
positive. So think about this. So for this to be negative right here, which ones are going to be negative?
X.
Anything with the x's, right?
Yeah.
Okay, so is cosine's going to be negative, right? Okay, ignore this. Cosine is going to be negative, isn't it? Because cosine is x over r. So cosine is negative here. What else? What else goes with the x? Tangent. Tangent's going to be negative here, right? Because it has a y and x. So that's going to be also negative. Anything else? There's 6 functions, remember?
Tangent, cotangent, secant.
Okay.
Tangent, secant.
Cotangent, right?
Yeah. You can do the opposite of tangent.
And secant.
Yeah.
All those will be negative. Does that make sense? Because there's one negative in those ones. But what happens if I get 2 negatives? It'll become positive, right? Okay, so let's talk about quadrant 3 now. In quadrant 3, it's going to look like this. Negative x, negative y. And the r value is always,
Positive.
thank you, r value is always positive. So what's going to be negative in this case?
Sine, cosine, secant, cosecant.
Okay, so sine, cosine, secant,
Cosecant.
cosecant. What about tangent and cotangent?
Those are positive.
Huh?
Those are positive.
Why are they positive?
Because you're dividing negative by negative.
Because tangent and cotangent is x over y or y over x, right? And both of my x and y are both negative. So 2 negatives will give you a positive. So over here, these ones here will be negative. let's go to quadrant 4. In quadrant 4, it is a positive x and a negative y. Again, it's why I can't have nice things. So which ones? So anything that goes with the y, right, is going to be negative. So what's going to be negative here? Sine, right? Sine is going to be negative. What else?
No, not cosine. Tangent.
Huh?
Tangent.
Tangent, very good. Anything else?
Cotangent.
Cotangent.
Cosecant.
Cosecant also. These are also negative. Wow, my penmanship is horrible today. There we go. Does that make sense now? And in quadrant 1, they're just all positive. So if they're not negative, therefore they must be positive. So there's going to be a whole stack of homework problems that are just asking about if it's positive or negative. And it's going to be like, all right, here's your point. Which ones are negative, which ones are positive? You're going to say sine is going to be positive, cosine is going to be negative, and what quadrant are they in? So you're going to use this right here to solve for these. And I think that's it for this one, and then I leave you alone. Yep. Actually, hold on. Determine the sides. Oh, yeah, no, it's this one right here. Function, angle, measure, standard position. Now, so for here, for A, 87 degrees. Where is 87 degrees? What quadrant is that?
Quadrant 1.
It's quadrant 1, right? So if I go back to quadrants and I'm looking by degrees, this one right here is 90. Over here is 180. Down here is 270 and 0/360. So if your angle is between 0 and 90,
Quadrant 1.
it's quadrant 1. Between 90 and 180, it's quadrant 2. There we go. So this is quadrant 1, right? So we're stating quadrant 1, and so let's go. Sine. What's sine going to be?
Y.
Positive or negative?
Positive.
Okay, that's all it's asking for. Cosine. What's cosine?
X over R.
Yep, and cosine in quadrant 1 is going to be?
Positive.
Very good. Tangent. 87 is y over x, and in quadrant 1 that is?
Positive.
Thank you. Next one's going to be cosecant. In quadrant 1, that's going to be? It's positive, right? Okay. Positive and secant and cotangent. How about that 300? Where's 300 end up at? It's quadrant 4. It is. Because quadrant 4 is between 270 and 360. 270 to 360, right? So, I'm going to say quadrant 4. And so there, sine, you could use that other one. You could use that other page. We know that sine there is going to be what? It's negative, right? You could just put a negative sign. Cosine. Very good, positive. Tangent. Negative. Cosecant. Cotangent. No, wait. Where am I at? Secant. Secant is? Very good. And cotangent. That's it. Hopefully you guys, it's not too bad. It's trying to get you guys working mentally, having an image of where everything is on the unit circle. So you have an idea of your X, Y's, and R's all the time. So I'll leave this up here. So make sure you like, share, and subscribe. Hit that notification button. And you guys like my awesome shirt right here? Look, from my merch store. From my merch store right there.